Okay, see, so yesterday we were discussing about salt intrusion. Okay, so what do you mean by salt intrusion? So salt intrusion എന്ന് പറഞ്ഞു കഴിഞ്ഞാല് the rising of salt water into the fresh water is called as salt intrusion. Okay, so in this picture it is very clearly seen. So this is a fresh water aquifer. Okay, so this is a aquifer which is actually containing the fresh water. So here they have digged a well. See, this is a well that is made for the irrigation purpose. Okay, so here also there is another well. Okay, so this is a sea level. Okay, so this is a sea level. So normally this is the boundary of the sea and the sea level and this continental crust. Okay, this oceanic crust and not oceanic crust, ഈ sea level ഈ ലാൻഡും ആയിട്ടുള്ള ഒരു ബൗണ്ടറി ആണ് this one. Okay, you can see the interface. Okay, so you're not supposed to have a salinity beyond this point. Okay, you are not supposed to have a salinity beyond this point, but due to the global warming and many other reasons, what is happening, the sea level, the salt water is crossing this boundary and it is rising to the freshwater aquifer. Okay, so you can see the salt water intrusion in this figure. See, this is the boundary, or you can say this is the interface up to which this is an interface up to which you should have the salt water. Beyond this interface you are not supposed to have the salt water, but here the salt water has intruded into the freshwater aquifer. See, so this is a freshwater aquifer. Okay, the salt water has been intruded over here. So what has happened, so fresh water has been mixed with the salt water and it is also contaminated with the salt water. Okay, so here we are having two wells. Okay, for the irrigation purpose, here there is one well, here there is another well. Okay, so the first well has been contaminated with the salt water. Okay, the first well has been contaminated with the salt water. Okay, so this is the second well which is not yet contaminated with the salt water, but you cannot be sure about it because the salt water will intrude and it will also reach here because of the global warming and many other reasons that we have discussed. Okay, ഈ വെള്ളം ഇങ്ങോട്ടേക്കും വരാനുള്ള ഒരു ചാൻസ് ഉണ്ട്. Okay, the salt water, because of its high pressure, it may intrude to this well also. Okay, so what is happening, can we use this water for the irrigation purpose, for the agriculture? We cannot use, because salt water, if you use salt water, it will reduce the productivity of the agriculture. Okay, so that is a picture of this salt water intrusion. So this is another picture that is occurring in the coastal areas. Okay, this is another picture of saltwater intrusion that is occurring in the coastal areas. Okay, this is the salt water. See, you can see the seawater intruding. Okay, okay, so this is the seawater. Now we have discussed the impact. Okay, we have discussed the impact of this sea waters. So that is the seawater intrusion means it is actually affecting both the human life, then vegetations, then what are all the activities which is depending upon the fresh water. Okay, all the activities which is depending upon the fresh water is affected by the seawater intrusion. Okay, so mainly the seawater intrusion has been occurring in the Atlantic and the Gulf Coast. Okay, these are the two regions which is worst affected with this salt water intrusion. Okay, because billions of people, they are having the lack of access to the fresh water because of the seawater intrusion. Okay, now the seawater intrusion, it also lead to the mud flats. Okay, it also lead to the mud flats. അതായത് ഇങ്ങനെ വെള്ള കളറിലായിട്ട് you can see ഈ മണ്ണിന്റെ മുകളിൽ വെള്ള കളർ പോലെ ഇങ്ങനെ മണ്ണ് കൂമ്പാരായി പോകും. Okay, so that is also another negative effect of this seawater intrusion. Okay, that is spread of mud flats. Okay, അതായത് വെജിറ്റേറ്റീവ് ഏരിയസിലേക്ക് ഈ മണ്ണ് ഇങ്ങനെ കൂമ്പാരമായിട്ട് ചെന്ന് കയറും. Okay, so that is another negative effect of this mud flats. So and then the negative effects of this seawater intrusion. Now coming to the most important theory that is related with the seawater intrusion. This is Guypen-Herzberg relationship. Okay, so this Guypen-Herzberg relation actually tells you about the seawater intrusion. Okay, this is the first physical formulation of seawater saltwater intrusion, which is made by W. Baden, G. Okay, Gijiben and A. Herzberg, thus called as Guypen-Herzberg relationship. Okay, so these are two person. Guypen is one person, Herzberg is another person. Okay, so these two person in the 18th century they have first spotted the saltwater intrusion. Okay, and also they have derived a formula for the saltwater intrusion. Okay, so they derived an analytical solution to approximate the intrusion behavior, which are based on the number of assumptions that do not hold in all field cases. Okay, so they have made a study on the saltwater intrusion and they have come to a conclusion to find out the approximate behavior of the saltwater intrusion, അതായത് how the saltwater intrusion is behaving അല്ലെങ്കിൽ ഇതിൻ്റെ ഒരു effect. Okay, to study about the, or you can say an approximate solution to the intrusion behavior. Okay, so they have derived a uh, solution for the saltwater intrusion. So we'll see what it is. Okay, so this is the equation, that is z is equal to rho f divided by rho s minus rho f into h. Okay, so this relation is very important. You have to study this equation. So you don't have to study the derivation and all, but you have to understand this equation, and you also have to study this equation. This pass for your university also. Okay, so in the figure they have actually shown you saltwater intrusion. Okay, so this is a salt water. Okay, so this is salt water. As you're seeing, this is a salt water interface, and this is a fresh water. So this is a sea flow. Okay, so the salt water ഇങ്ങോട്ടേക്ക് കയറി കയറി വരികയാണ്. ഇതാണ് സീ, ഇത് ഫ്രഷ് വാട്ടർ ആണ്. അപ്പോൾ ഈ സോൾട്ട് വാട്ടർ ഇങ്ങോട്ടേക്ക് കയറി കയറി വരികയാണ്. So this, based on this, they have made a relation. Okay, so here Z stand for the thickness of the fresh water zone below the sea level. Okay, so this is the Z is the thickness of the fresh water zone below the sea level. അതായത് ഫ്രഷ് വാട്ടർ സോണിന്റെ ഡെപ്ത് ആണ്, യു ആർ ടേക്കിംഗ് ഇറ്റ് ആസ് Z. Okay, H is the thickness of fresh water zone above the sea level. Okay, H എന്ന് പറയുമ്പോൾ this is the H. Okay, so H is actually അതും depth of freshwater zone, that is above the sea level. Okay, Z എന്ന് പറയുമ്പോൾ this is below the sea level, and H, it stands for above the sea level. Okay, so this is the sea level. Okay, this is the sea level. അപ്പോൾ sea level താഴെയുള്ള നല്ല വെള്ളത്തിന്റെ depth. Okay, so depth of fresh water below the sea level is taken as Z, and depth of fresh water above the sea level is taken as H. Okay, so you can see from this figure itself, it is pretty clear. Okay, and rho f is the intensity of the fresh water, that is 1 gram per centimeter cube. Okay, 1 gram in CGS unit, we can say it is 1 gram per centimeter cube. And rho s is the density of the salt water. Rho s is the density of the salt water, that is 1.025 gram per centimeter cube. Okay, so this is the equation. So this is the equation, z is equal to rho f divided by rho s minus rho f into hf. Okay, so h is depth. Okay, depth of fresh water above the sea level, and z is depth of fresh water below the sea level, and this all stands for the density of fresh water. F stands for fresh water, and this stands for density of the salt water. Okay, now what it is actually stating is that Z is equal to 40 HF. What does it mean? Okay, Z is equal to 40 HF. Okay, so we'll study about this equation. So actually states that The analysis assumes that the hydrostatic conditions in a homogeneous unconfined coastal aquifer. According to this relation, if the water table in an unconfined coastal aquifer is lowered by 1 meter, salt water interface will rise by 40 meters. Okay, so see this. ഇതാണ് നമ്മൾ നേരത്തെ പറഞ്ഞ ഈ റിലേഷൻ. Z is equal to 40F. Okay, so Z is equal to 40F. Okay, so Z is equal to 40F means according to the Herzberg equation, they are telling that 1 meter നമ്മുടെ വാട്ടർ ടേബിൾ താഴേക്ക് പോയി കഴിഞ്ഞാൽ 40 meter salt water റൈസ് ചെയ്യുമെന്ന് പറയുന്നത്. Okay, so if the 1 meter freshwater aquifer, or can say near the coastal regions, okay, 1 meter freshwater aquifer in the coastal region is lowered, correspondingly salt water will rise by 40 meters. Okay, salt water is rising by 40 meters. Okay, so that is what Heisen-Herzberg is stating. Okay, so Heisen-Herzberg ratio states that for every foot of a fresh water in an unconfined aquifer above the sea level, there will be a 40 feet of freshwater aquifer in the freshwater aquifer below the sea level. ഓക്കെ, അതായത് 1 മീറ്റർ താഴെ പോകുന്നതിനനുസരിച്ച് 1 മീറ്റർ നമ്മുടെ കടലിലാണെങ്കിൽ 1 മീറ്റർ വെള്ളം താഴെ പോയി കഴിഞ്ഞാൽ 40 മീറ്റർ സോൾട്ട് വാട്ടറാണ് റേസ് ചെയ്യുന്നത്. Okay, so that is the concept that is put forward by these two people. Okay, Z is equal to 40 HF. They have formulated this equation. Okay, they have formulated this equation, that is rho F divided by rho S minus rho F is equal to HF. Okay, so by using this equation you can find out the H. Okay, you can find out the height of fresh water below the sea level. Okay, you can find out rho, you know, density of the fresh water, you know, density of the salt water also, you know. Okay, so for the Z you can substitute for 40 HF. Okay, if you substitute 40 HF, now this you can find out HF, right? That is only unknown that is remaining. Okay, but unknown 40 HF മാത്രമായിരിക്കും, so you can find out it. Okay, okay, reverse also you can do it. If you do in a reverse also, you can find out the depth of the freshwater zone above the sea level. Okay, so this equation, this is very important. You have to by heart both this equation. Okay, equation Z is equal to 40 F, and also other equation also you have to understand, and also you have to understand this concept also. So this is very important. This is the only concept. This is the concept that is put forward by the guys and Herzberg. Okay, now so how okay, so how to manage the saltwater intrusion? Okay, how will you control the saltwater intrusion? Okay, so using that equation you can calculate how much of water level, how much of salt water is rising. Okay, എത്രത്തോളം salt water ആണ് റൈസ് ചെയ്യുന്നതെന്ന് കണ്ടുപിടിക്കാൻ പറ്റും. Now that's not enough. We need to control the saltwater intrusion. First one is to maintain a proper balance between the water being pumped from an aquifer and water which is being recharged. Okay, so first thing you have to do that you have to maintain a proper balance between the water that is pumped and also water that is recharged. അതായത് നമ്മൾ വെള്ളം from the certain well, okay, from using the infiltration galleries അല്ലെങ്കിൽ using the borers, we are taking a lot of ground waters. Okay, അപ്പം നമ്മൾ കുഴിച്ചെടുക്കുന്ന വെള്ളം ഇങ്ങനെ റീചാർജ് ആവുന്നതും തമ്മിൽ നമ്മളൊരു പ്രോപ്പർ ബാലൻസ് മെയിൻറ്റെയിൻ ചെയ്യണം. യു ഷുഡ് അണ്ടർസ്റ്റാൻഡ് ദ പ്രോപ്പർ റിലേഷൻ ബിറ്റ്വീൻ ദ ടു. ഓക്കെ, ചില കിണറിൽ ഉറവ കുറവായിരിക്കും, Okay, so from such wells you should not pump too much of water. Okay, first you should understand the land. If the land is having a deficiency of water, you should not pump too much of water from the well. Okay, the second one is constant monitoring of the salt water interface is necessary in determining the proper management. Same thing, you have to maintain a constant monitoring of the salt water interface. അതായത് you have seen here, like in this figure you have seen, this is the interface, salt water interface. Okay, so this is a salt water interface. So you have to maintain, you have to closely observe this salt water interface. ഒന്ന് ശ്രദ്ധിക്കണം. Okay, so always see that the boundary has not been crossed by the salt water. Effort towards the promotion of water conservation and restricting withdrawals from the coastal aquifers have been in a focus in many areas. That is, you have to reduce the consumption of the water and you have to promote the water conservation measures. Okay, so mainly this is occurring to the lowering of water table. Okay, but you should not allow pumping of too much of water. Okay, you should always encourage water conservation measures. Using alternative freshwater sources have also been encouraged. Ocean water desalination plants are showing up in the coastal regions around the world. Okay, so you should find some other way to find out the fresh water. Okay, not just always depend upon the wells. You have to find some other method. That is, you can go for a water treatment plants. You should go for a recycling of water. Okay, find an alternative method. Okay, and also some other method is that you can also install ഡീസാലിനേഷൻ പ്ലാന്റ്സ്. ഡീസാലിനേഷൻ എന്ന് വെച്ച് കഴിഞ്ഞാൽ വെള്ളത്തിൽ നിന്ന് ഉപ്പ് വലിച്ചെടുത്തിട്ട് വെള്ളം മാത്രം പമ്പ് ചെയ്യുന്ന ഒരു പ്ലാന്റിനാണ് യു കോളിംഗ് ഇറ്റ് ആസ് ഡീസാലിനേഷൻ പ്ലാന്റ്. ദിസ് ഡീസാലിനേഷൻ പ്ലാന്റ് is available in Tamil Nadu. If you ever been to Tamil Nadu region, the nearby coastal region, they are installing a lot of desalination plants. What means from the ocean water they will remove the salinity. That is called as desalination. They will remove the salinity and they will use that water for the daily purpose. Okay, so you can install this desalination plant so that you can reduce the use of groundwater. So far there are no options for the fresh water. Efforts to maintain groundwater levels by ponding surface water and storm water surface or using river water to recharge the groundwater table have been successfully implemented. Okay, so in a certain regions there won't be fresh waters. Okay, in certain regions there will be freshwater deficiency now. So in such regions you can go for the ponding of the surface water. അതായത് നമ്മൾ വെള്ളം കെട്ടി നിർത്തുക. ഓക്കെ, എവിടെയെങ്കിലും ഒരു സ്ഥലത്ത് വെള്ളം ബണ്ട് പോലെ കെട്ടിയിട്ട് വെള്ളം കെട്ടി നിർത്തുക. ദാറ്റ് ഈസ് കോൾഡ് ആസ് പോണ്ടിങ് ഓഫ് സർഫേസ് വാട്ടർ. സോ ദാറ്റ് വാട്ടർ ടേബിൾ വിൽ ബി റൈസിങ്. അപ്പം വെള്ളം കുറച്ച് താഴേക്ക് ഇറങ്ങി പോകുമ്പോൾ വാട്ടർ വിൽ ബി ഇൻഫിൽട്രേറ്റഡ് ആൻഡ് ഓൾസോ വാട്ട് വിൽ ഹാപ്പൻ, ദ വാട്ടർ ടേബിൾ റൈസസ്. ഓക്കെ, സോ and also you can promote the storm water runoff, മഴ വെള്ളം കെട്ടി നിർത്തുക, or you can use the river water to recharge. Okay, so when you are using such methods, what is happening, the groundwater will get recharged. Okay, the groundwater will get recharged. Okay, you can use such techniques. അത് നമ്മുടെ മഴവെള്ള സംഭരണി ഒക്കെ പോലെ. Okay, next is aquifer storage and recovery systems help to restore aquifer that have experienced a long-term declines in water levels due to overpumping. Okay, so that's a method, that is aquifer storage recovery system, ASR system. Okay, so this is a system which will actually help you to recharge the aquifers. അക്വിഫറിനെ റീചാർജ് ചെയ്യുന്ന ഒരു മെത്തേഡാണ് അല്ലെങ്കിൽ ഒരു സിസ്റ്റമാണ് അക്വിഫർ സ്റ്റോറേജ് റിക്കവറി സിസ്റ്റം. Okay, so you can use this system to recharge the aquifer and also to reduce the over pumping. We can reduce the over pumping. അത് കുറേ വെള്ളം പമ്പ് ചെയ്യുന്നത് നമുക്ക് റെഡ്യൂസ് ചെയ്തിട്ട് ഇതുപോലുള്ള മെത്തേഡ്സ് ഇൻസ്റ്റാൾ ചെയ്യാം, സോ ദാറ്റ് ദ അക്വിഫേഴ്സ് വിൽ ഗെറ്റ് റീചാർജ്ഡ്. Okay, so this is, you can this is another one thing, that is physical separation. That is, you can build a barriers, the construction of artificial subsurface barriers. അതായത് ഭൂമിക്കടിയിൽ you can create a barrier between salt water and the fresh waters. Okay, this is a physical method that can be adopted. അതായത്, so if you see here, Okay, so here this is salt water, this is fresh water. So here you can construct a barriers. ഒരു barrier പോലെ ഭൂമിന്റെ അടിയിൽ കുഴിക്കുകയല്ല construct ചെയ്യുക. Okay, so subsurface barriers can be constructed to so that the salt water is not crossing the barrier. അതായത് നമ്മൾ ഭൂമിന്റെ അടിയിൽ എന്തെങ്കിലും ഇങ്ങനെ കെട്ട് പോലെ കൺസ്ട്രക്ട് ചെയ്ത് കൊടുക്കുക. So that the salt water won't be crossing the boundary. Construction of artificial subsurface barriers. Next one is you can go for the recharge pits. Okay, so artificial recharge in the areas of production wells. Okay, so you can create artificial recharge for the wells. That is വെള്ളം കെട്ടി നിർത്തുക. That's it. Artificial recharge എന്ന് വെച്ചാൽ you can go for the ponding. You can construct a big ponds and you can അവിടെ വെള്ളം കെട്ടി നിർത്തുക. Ponds ഒക്കെ പോലെ വെള്ളം കെട്ടി നിർത്തുക. So what will happen? That water will infiltrate down and it will recharge the wells. That's a recharge pits. Next is injection belts. That is to create a pressure ridge. That is to barrier to prevent the intrusion. Okay, that is you can create a pressure ridge between the salt water and the fresh water so that it will reduce the intrusion, or you can say it will prevent the intrusion. Okay, you can create a pressure ridge between the salt water and fresh water so that it will reduce the intrusion. Okay, so you can see one of the example of the deep recharge wells. Okay, so this is a recharge well that has been constructed. Okay, so this is not much important actually. So in saltwater intrusion you can expect the effects and also this relation is very much important. So that's about the saltwater intrusion. പിന്നെ ബാക്കി preventive measures അത്ര important അല്ല. You can just go through it. That's it. So now today we'll talk about a new topic. Okay. The next topic is we'll today learn about the groundwater exploration. Okay. So how will you explore how will you find out the groundwater? Okay. Okay, so suppose if you want to dig any wells, what will you do? What will you do? What is the general practice that has been done? Okay, നമ്മൾ കിണറൊക്കെ കുഴിക്കണമെങ്കിൽ എന്താ ചെയ്യാ? Tell me, what will you do? Okay, so let's start. So next up is to okay, so can you see the PPT now? Can you see the PPT? Please respond. Okay. The next topic is we are going to study about the groundwater exploration. So how will you find out that at a particular point the groundwater is there? Okay. Suppose you all has been passed out. Okay, നിങ്ങൾ pass out ആയിട്ട് you are working in some geological department and someone is asking you to find whether there is a groundwater or not, he need to dig a well. So how will you find out? Okay, so നിങ്ങൾക്ക് നോക്കി പറയാന്ന് പറയുമ്പോൾ that is not a very appreciable method. Sometimes you may go wrong also. Okay, പണ്ട് കാലത്തൊക്കെ ആണെങ്കിൽ we are having people who will come and they will select a particular spot. Okay, so that is another traditional method. We are not following all this method. We are technical people. We have to follow the science. So here we are having different method for the groundwater exploration. So we'll study about one of the latest method, that is exploring groundwater using electrical resistivity method. Okay, exploring groundwater using electrical resistivity method. That is, we are going to study here. We are not studying the groundwater. We are not going to spot the groundwater. Instead, at a particular region, you will study the different strata that is lying below the earth. Okay, at a particular point you will go and you'll choose a point and you will study the strata below the earth. Okay, ആ ഒരു എർത്തിന് താഴെ എന്തൊക്കെ സ്ട്രാറ്റാസ് ആണല്ലോ നമുക്ക് പഠിക്കും. Okay, you will see different types of rocks. Okay, and you will go deep inside and whether you will and you will find out whether there is groundwater or not. Okay, so this using this groundwater exploration by electrical resistivity method, you are not just exploring the groundwater, you are also exploring the nature of the geological features below the earth surface. Okay, earth surface താഴെയുള്ള ജിയോളജിക്കൽ ഫീച്ചേഴ്സിന്റെ ഫുൾ ഡീറ്റെയിൽസും കൂടിയാണ് നിങ്ങൾ കളക്ട് ചെയ്യുന്നത്. Okay, you are not just collecting the groundwater. അതിന്റെ താഴെ മേ ബി ദർ ഗ്രൗണ്ട് വാട്ടർ ഇസ് പ്രസന്റ് ഓർ നോട്ട്, പക്ഷേ യു വിൽ സ്റ്റഡി അബൌട്ട് ദ full strata using this electrical resistivity method. Okay, okay, we'll start it. So in the areas where surface water is not available, groundwater constitutes a significant part of the active freshwater resources of the world and is dependable source for all our needs. Definitely, like, wherever the surface water is not available, you have to go for the groundwater. You have to find water is the most important thing in our all life. Okay, we cannot live without water. Okay, so if there is a sufficiency of surface water, definitely you have to go for the groundwater. Okay, so how will you find out where is the groundwater? Which aquifer contain the groundwater? Okay, which rock is having the groundwater? ഏത് റോക്കിന്റെ താഴെയാണ് ഈ ഗ്രൗണ്ട് വാട്ടർ ഉള്ളത്? Okay, so so this is where electrical resistivity method is gaining its importance. Okay, so electrical resistivity method means all the geological formation have a property called electrical resistivity, which determines the ease with which electric current flow through it. This resistivity is expressed in ohms meters and is expressed and indicated by the symbol P. Okay, so what is electrical resistivity method? So all the geological formations, okay, it is having a property which is called as electrical resistivity. That means the flow of the current through it. Okay, geological formation വെച്ചാൽ നമ്മൾ ഭൂമിയുടെ താഴേക്ക് പോയി കഴിഞ്ഞാൽ you will see different types of sand. Okay, you can see different types of rocks. Okay, maybe you can see the water table also. അല്ലെ, നമ്മൾ ഭൂമിന്റെ അടിയിലേക്ക് ഇത്രയും സംഭവമാണ് നമ്മൾ കാണാൻ പോകുന്നത്. You can see sand, you can see rock, and you can also see water table. Okay, so geological formation, whatever it is, okay, whatever the geological formation is, it is having an electrical resistivity. What do you mean by electrical resistivity? That means the flow of that is resistance of electric flow through it. Electric current അതിലൂടെ പാസ് ചെയ്യുന്നതിന്റെ റെസിസ്റ്റൻസിനെയാണ് യു കോളിംഗ് ഇറ്റ് ആസ് electrical resistivity. Okay, that is resist, or other words you can say resistivity, which is offered by the geological formation when an electric current is flowing through it. Okay, so every geological formation, maybe it is a rock, it is having electrical resistivity. Coming to a sand, it is having electrical resistivity. Coming to a clay, it is having a electrical resistivity. Okay, some weathered materials below the earth material, it is also having electrical resistivity. Coming to water, it is also having electrical resistivity. You know, the water will conduct electricity, right? വെള്ളത്തിൽ തൊട്ട് നമ്മൾ അറിയില്ലേ ഷോക്ക് അടിക്കും പെട്ടെന്ന്. It is also having electrical resistivity. That is, it will allow the water to pass through it. Okay, so electrical resistivity means the property of the materials, that is the resistance of a material when electric current is passing through it. Okay, ഇപ്പോൾ ഒരു ഇലക്ട്രിക് കറണ്ട് പാസ് ചെയ്യുമ്പോൾ എത്രത്തോളം റെസിസ്റ്റൻസ് ആണ് അത് ഓഫർ ചെയ്യുന്നത്, that is called as electrical resistivity. Okay, so the resistivity, it is expressed in ohm meters and it is also indicated by the symbol P. Okay, now we are using how this electrical resistivity is method used to study the geophysical exploration, or you can say the geological exploration. Now, the electrical resistivity of the rock formation. The electrical resistivity of the rock formation limits the amount of current passing through the formation and when the electrical potential is applied. Okay, so that's it. നേരത്തെ പറഞ്ഞ സെയിം സംഭവം തന്നെ. Okay, when through the geological formation, when you allow the current to pass through it, it will offer a resistance. Okay, it will offer a resistance. Okay, so what we are doing, we will measure this resistance and you will find out which material it is. Okay, you will measure this resistance. Suppose or a sand, see this below the earth surface. Okay, so this is the earth surface. Okay, so you are passing current through it. Okay, you are passing current. So maybe here you can see some sand, here you can see some rock, here you can see some water table. Okay, so when you are allowing the current to pass, what will happen? ഈ കറന്റ് ഈ സാൻഡിലൂടെ പാസ് ചെയ്യുന്ന സ്പീഡിലായിരിക്കില്ല റോക്കിലൂടെ പാസ് ചെയ്യുക. ഓക്കെ, ഈ റോക്കിലൂടെ പാസ് ചെയ്യുന്ന സ്പീഡിലായിരിക്കില്ല വാട്ടറിലൂടെ പാസ് ചെയ്യുക. Okay, that means the sand will give a resistance, okay, which is of different nature. A rock will give a resistance which will be different, and water will also offer a resistance which is also different. Okay, so based on this resistance, അവർ കൊടുക്കുന്ന റെസിസ്റ്റൻസ് വെച്ചിട്ട് you can calculate the material that is underlying. എന്താണ് മെറ്റീരിയൽ നമുക്ക് കണ്ടുപിടിക്കാൻ പറ്റും. So that is the basic principle that is used in the electrical resistivity method. So that's what they have mentioned here. Okay, that is electrical resistivity of rock formation limits the amount of current passing through it. Okay, so the rock formation, it will limit the amount of current that is passing through the formation when an electrical potential is applied. Okay, the formation of it limits the amount of current passing through it, or you can say the same resistance. So electrical resistance is the resistance of the volume of the material to the flow of electric current. Okay, just now we have discussed it. Okay, it means electrical resistivity means the resistance of the volume of the material for the flow of the current. Okay, second one, the current is introduced into the ground through a pair of electrodes. Okay, so here you can see they have installed a pair of electrodes. So through these electrodes, the current will be introduced into the ground surface. Resulting potential difference will be measured by another pair of potential electrodes. So here they have installed a potential electrode also. So you can see here they have installed a potential electrodes also. Okay, so the potential difference will be measured by these two potential electrodes. Okay, so from this you can calculate the apparent resistivity. Okay, so from this we can calculate the apparent resistivity of the electric current. Okay, and using this apparent electricity, now we can predict the material which is lying below the earth surface. Okay, so see, you can see from this figure is pretty much clear. Okay, so this is the electrodes. that has been installed into the ground, and this through this electrodes electric current is introduced into the ground surface, and here they have installed a potential difference. You can see the voltmeter. Okay, so from this we can calculate the resistance that is offered by a particular region. From suppose maybe this is some sand, this is a rock, this is some another kind of sand, and here maybe this is a water table, and this is some other kind of rock. Okay, so the bedrocks sand you have a different sedimentary rock and metamorphic rocks and different types of rock. Okay, so you can see by here using this voltmeter you can calculate the resistance which is offered by each layers. Okay, and we can calculate the depth of water table, at what depth the water table is lying from the earth's surface. And also additional to it, you can also find out the different strata that is lying below the earth surface. അതായത് ഇത് ഏത് സാൻഡ്, ഇവിടെ ഏത് type of sand ആണ്, okay, which kind of sand it is there. Okay, you can see the rock, what kind of rock is there, what is the composition of the rock. Okay, what is the chemical composition of the rock, what mineral is composed in the rock. After you can see the sand, what kind of sand it is, okay, how it is behaving, what is its chemical composition, all these things you can find out. Okay, so I think it's almost time now. You can pause your name to mark the attendance. Okay, so understand the concept. Electrical resistivity എന്ന് പറഞ്ഞാൽ ഇത്രേ ഉള്ളൂ. ഇതാണ് അതിന്റെ ബേസിക് ആയിട്ടുള്ള ഒരു കൺസെപ്റ്റ്. ഈ ഒരു കൺസെപ്റ്റ് മനസ്സിലാക്കിയാൽ മതി. ഓക്കെ, and one more thing about the assignment, you can submit it at the end of module. Okay, third module തീർന്ന ശേഷം we can submit it. And also see, it is for the 5 marks. Okay, assignment I have given for 5 marks, so you have to just write for the 5 marks. So all has to post your attendance. Okay, what about the remaining? Only 21 people has posted their names. What about the remaining?